Good morning. My name is Kevin. In today's power engineering conundrum, I would like to discuss an option never thought of generally by the trade when it comes to the selection of the circuit breaker and especially the cable thereof. So without ado, let's get into our session. So today, power engineering conundrum is about the cable selection. So let's have a look at a number of things and let's have a look at the background to this. So when we normally determine what correct cable we're going to use, we look traditionally at the load, we check the method of installation to be used, and with the worst value indicator, do a volt drop to keep this typically below 5%. And then we go on to the selection of the required circuit breaker. But there is a little known fact that the circuit breaker that has been certified with a certain conductor size as per the product specifications and manufacturing thereof. The warning here is to provide an optimal cable protection that should be factored into the calculations also. Now, this is not generally known by the trade. Of course, it's more of a manufacturing type of thing. And you could, in fact, choose a different both a miniature circuit breaker or molded case, and the cable size could be slightly out of sync, and it could have a negative effect onto the performance of a circuit breaker. So generally speaking, the circuit breaker, as we said, has been certified using some copper conductive material, and it's generally indicated with a PVC insulation, that being the most popular for many, many years type. And moving from any of the current types of insulation would require quite a bit of care. So if we're using PVC and copper, generally we are in the standard that has been applied during the tests to the circuit breakers. The allowable conductor is obviously protected by the circuit breaker. That's its whole and primary function, really. And other alternatives to PVC, now PVC is considered to be a 70 degrees Kelvin type temperature rise, so it's allowed to get to that without damage. You do get some rubbers out there, of course, the nitrile type rubbers and the typical rubbers. They could be anything from a 60 to 85 degree Kelvin. And we're all aware today the massive advancement of silicone in many things, including cable. And that cable could withstand 150 to 180 degrees Kelvin, which is a huge thing. Obviously, the net effect on that type of temperature, if you're using that type of cable, you're going to have a problem with the circuit breaker. There's no doubt that over time, you will definitely have something go wrong somewhere down the line where you have a nuisance tripping or a failure to do something using that type of cable. Now, generally speaking, cable connections out of the panel and that type of thing have been done. I will do a small talk one day on inside the panel, because most of these rubber type connections are not made external to the circuit breaker to the load area. They are more internal in on the panel. So this type of thing, this type of course can just alert you to some of the knowledge that you need if you're working with things and problems on sites occur sometime down in the future. You call to a site which is not behaving correctly and the customer is not getting it right, and you might just have that little bit of knowledge from here, hopefully, that allows you to solve the customer's problem. So we're going to look at something like a typical example here so we can follow along. We're saying you need 100 amp three-phase power supply to something like 25 meters away from a main DB. The options obviously open at any one time are typically single core cables or a 3-core cable, to be determined really in this little mini session that we can go through here. Kind of, if we look at where we're going to look at these installation methods, could be buried in a wall underground or on a cable tray. And this might be, and why I've done that is because these sort of two options highlight some of the issues with the cable selection. We've said the local ambient is 40 degrees. Important to know that because that plays a part in the cable selection as well. And we're going to try and determine some feeder miniature circuit breaker or a molded case circuit breaker. And in this case, we're not really going to look too much at the bus bar to breaker type cable feeders to that, but we will just make some comment on what we have there. So if we have a look at the tables in the SANS document, and you will get to that a little bit down here, we will find that, let's have a look at those tables first. So if we have a look at 6.3a, unarmored copper multi-core PVC, typical 3-core type cable that we might be using. And we look at what we're given, M1, M2, M3, M4, the methods of supply, or where that cable could be laid or held or done. And we're not looking at any other techniques. We're looking at the basic technique here. We're not looking at things like how the cable will be, multi-cables in ground, etc., which could have a knock-on effect here as well. I've gone for a basic type of arrangement. So we said that we could have a look at some single core cables, first 25 meters, not particularly long. And we could go for unarmored copper multi-core PVC. And we've chosen PVC so we don't clutter up this. If we had aluminium, for instance, there would be maybe a little bit extra worry and concern about the current carrying capacity of aluminium in much the same way that it would form in this one. So if we have a look for our 100 amp base supply, 25 mil, 35 and 50 mil appear to be the type of product that we would be looking at, just looking at the numbers. I've highlighted all the areas where the potential for around about the 100 amp supply would be met with the cables. And we can see that under some construction, we would get a 25 mil cable at M4, 101. And the same would be up to 153 amps with a 50 mil. So we've said that underground, which would be, I'm not quite sure which one offhand, but M4 would be maybe a cable type, like a cable, what would you call it? A cable tray type arrangement on a wall, open, so it can easily bleed off temperature. And in the unarmored single core are much the same. And of course, all the red is the possibility that we could consider those cables under those conditions to actually be used. So anything from a 25 to a 50 mil. We must also factor in that we said the local ambient is given at 40 degrees. And so the correction factor here is 0.87 times these values. Sorry. And we can see that the one I eventually chose, and I'll just mention, I'll go back into a bit of the details, is 109 amps at 40 degrees, which is actually this particular one, which gives 109 amps once we do the factor correction for temperature, which we've got to do. So looking at the table, there's an option here, anything from, so we could have a look and say, gee, anything from 25 to 50 mils cable could be used. Now, we need to have a look then at what we are actually looking at today from the angle we're actually approaching this. And if we have a look at that, these are the conductor sizes actually specified for the testing of the breaker in the certification phase. So if we're looking at 100 amps approximately, and this is where we said that we would like around 100 amps for our cable, we can immediately see that the cable used, the PVC cable used for this test of the 100 amp breaker was 35 millimeters squared. And this is the punchline that I want to get over to the industry, is that this portion is not generally known by people other than the manufacturers of the actual circuit breakers themselves, because this is a vitally important part. if you were to deviate from this in terms of, let's say, for instance, you chose a 25 mil, and we saw 25 mils was a possibility on the previous tables. That is a breaker of 80 amps. So when we start to put a 25 amp conductor on a 100 amp breaker, it's going to traditionally run warmer, and it's not going to remove the heat out the breaker, and we can expect an offset of that breaker's performance. Specifically, and we talk here very specifically to circuit breakers which are of a thermal type mechanism. So anything that uses heat and we vary the conductor has a potential to change the characteristics of that circuit breaker. You've got both things. You've got the normal cable size type arrangement, and you've got some bus bars. So what the cable manufacturer, sorry, what the circuit breaker manufacturer has to do is he has to test any of these breakers with those size levels with that. And I've included here as millimeters squared on the bus bars, because obviously you do get a variation on the bus bar widths and thicknesses, etc., etc. And the net effect is that you need that millimeters squared as opposed to the actual level, although obviously surface area could play a part in here. So when we have a look at that, we can see immediately that circuit breaker has some net effect. The possibility is definitely there. So we need to also have a look at how these circuit breakers are tested, because this is, I think, a little bit important here in the way that it's actually tested in the certification process, because it is slightly different to what you have in the real world. Because obviously in the real world, the circuit breaker will fit in a panel of some sort, some form of holding device. Now, these tests on the actual performance criteria, and they've done this in open air, I think, which does complicate matters slightly, because they'd all be eventually put into a panel board, as we said. But you can't standardize on a panel board. There's no such standardized panel board in existence. So the tests are done in the circuit breaker in an open air status condition. And the breaker has cable lengths where the tails on each connection area are at least 1 meter long. Again, in reality, may never be as long as that, but this is in fact the specified test using the cables as we saw on the other chart. If we chose a cable thinner or thicker, the variation in the performance would definitely change on that breaker. We could also say that a breaker at 100 amps does not trip at 100 amps. Most of them have an inverse tripping characteristic, which means that they will start to trip at 135% traditionally, somewhere at that level. And they get faster as the current gets higher. So at 200%, the breaker might be 8 to 12 minutes to trip, and 100 amp breaker at 135% could be, I don't know, 50 to 100 minutes. And that's quite a long time, an hour before the breaker trips. And yeah, we've had feedback where people said, well, I've put 120% on the breaker and it never tripped out. Well, whoopie-doo, the breaker will never trip out. It's not designed to trip at that level. It's perfectly okay. The cable will get jolly hot, we understand, but it will not get catastrophically hot. Of course, ambient makes a difference. You know, we are talking about cable at 30 degrees, and the moment we close the panel board up, 30 degrees is pretty hard to maintain in a running condition. Sometimes there's a certain, I'd say, a rule of thumb being provided, and some wiring codes actually do specify this, that a circuit breaker, this can all be rather confusing to somebody that's trying to get the right cable out and not really understanding the direction of this. So some of the wiring codes say a circuit breaker should never be using or never have 100% of load above the 80% threshold level, giving that variation. And this, in effect, really abates a lot of the problems that would or could occur due to variations in slight temperatures and cable variations, et cetera, and also somewhat in the way that it's done there. Thermal breakers have derating curves as per the one we're looking at here. So a breaker that's chosen or given as a 40-degree breaker type, and you do get 30-degree breaker types, you get 40-degree taper, you get 50, and you even get some higher. So if we have a look here, a 100 amp breaker at 40 degrees on a 40-degree type curve will carry 100% of its load in that correct cable size, which is in what we saw there was 35 square millimeter as per the given. Any other variation in the temperature changes the characteristics of that breaker. So this is a typical thermal type breaker out there. And if you're going to either go down lower, as in this is 25 degrees, you can see that it'll hold 108 and offset. And this is all thermal type breakers. So if you're using PVC cables, be aware that you've got a variation in the performance of the breaker, which is offset somewhat by its actual thermal temperature. This leads us to another point where we should very, very carefully suggest that if a circuit breaker is sitting in a very warm panel board, and it feeds to a very cold load area. In other words, the cable goes out in a much lower reduced status of temperature. The performance is different to where it's actually being seen, because the performance will be measured by that circuit breaker in its local environment. So it's very important where you have a, let's say, a hot panel board and a cold load area, or the other way around, a cold panel board area and a very hot load area where the cable is under stress from additional temperatures around it. So it will not have optimal protection from the cable, which is in a cold state, which will then take longer to trip. So that's kind of where we're going to have a look at today. I just want to go back to the selection. So when we had a look at the selection, we could choose anything from a 25, 35, and 50 mil cable. We looked at that. If you look at the volt drop at 25 meters, now you can do that either by the calculation method, or you can look at the maximum length of cable, and you can see that all of those cables at 25 meters all would exceed the 5%, well, not exceed the 5%, it would be lower than the 5%. And there would be no need to worry about the volt drop at that point. The 25 millimeter cable, millimeter square cable is rather borderline, and seeing as the breaker requires a 35 mil type effective cable, we'd probably rule that out. It certainly would be a borderline cable use. At 100 amps, we have other selections here, because we could have a miniature circuit breaker and we could have a molded case circuit breaker. We could say that the 100 amp would be cheaper than a 125. So we wouldn't really, if you have a look on there, you could actually see that possibly a circuit breaker in the 125 amp class could be specified. 100 amp circuit breaker kind of would be cheaper than the 125. The molded case we need to have a look at, because if we were to, let's say, go with the 50 mil cable, because kind of we had that in our toolbox and, well, we've got 25 meters of it, why not? Well, why not indeed? You know, it's paid for, it's done, it could go in there. The only requirement there would be you'd have to look at the captive terminals, because the miniature circuit breakers generally are not lug type connections on there. And you'd have to look at whether the 50 mil would in fact fit inside the captive type terminal. So here's another direction from the circuit breaker manufacturers. So you saw during the test there, the specified cable would be 35 square. And in fact, the specification calls for the next size cable to be a possibility to have it in the clamp system. So the breaker, the 100 amp breaker, is in fact equipped to go to a 50 mil square cable. By design, and that's kind of it's a forced design, obviously, it's a specification requirement. So that's a possibility as well. So, you know, here we have an opportunity to go 100 amp circuit breaker. The cheapest option would be the 100 rather than 125. The A miniature type would be definitely cheaper than most of any of the brands of a more industrial type, molded case type. And yes, if we had to use 50mm cable, so all fits that. Of course, the alternatives, and there are companies like CBI which offer ambient temperature non-effect type breakers, which offer no effect on that due to their technology. They're a non-thermal technology type, hydraulic magnetic in this case, would in fact also offer some benefit possibly in using. So yeah, it's not as easy as we just do here. Obviously, I've looked at things like Andrew said, I'll probably go with a 3-core, 3-phase unarmored type of arrangement fitted on a clip tray of some sort. Many trays, there's many versions out there. It offers quite a lot of latitude to have higher temperatures and higher current there. So there's good reserve on that cable for connection compromise. Yeah, 35mm typically in this case feeds the breaker size. So the point of today was to have a look at all of these options, but with a view from the circuit breaker manufacturer's side as an added complication. As I said, you see nothing of this in any of the wiring codes per se, but this is to bring the knowledge out there, because one day you might be called to a site where this type of arrangement looks and effectively looks like it fitted the wiring code, but the breaker, and I'm not saying it's a faulty breaker, I'm saying the breaker and the technique of a thermal breaker may have an effect on what's happening on that site. So I hope you got something out of today's discussion on this. It does sound a heck of a lot more complex than originally thought of, I'm sure. And the idea here is not to feed that thing, is to give you some additional information so that you think a little bit deeper into the situation that may or may occur. And may in fact result in an application down the line where you actually say the circuit breaker is faulty. And being in that game for many years, you do get a lot of people which always claim a circuit breaker is the thing that's not working, when a poor selection or a selection that doesn't take all accountable issues into a requirement haven't always been done correctly. And we do see this, and the biggest number of circuit breakers in the world are thermal type. They by far outweigh all the other technologies at this time of the discussion. But they, because they work on thermal, they have to have a regard for that thermal variation. If it varies from the ideal, that's the ideal of the circuit breaker, and that's an ideal from the actual calculations based on. And these references, just as a reference here, come from the SANS wiring code 556, which is a circuit breaker specification, and the IEC type of thing, which is exactly the same for circuit breakers, again 60947. Thank you very much. I hope this doesn't make it more complex going forward, but gives you some idea that we're getting to a point where we've got to add a few other extras in.